We are covering the essentials of waves, sound, and light for the AFOQT physical science subtest. Understanding these concepts is critical, as they form the basis for many questions on the exam. Let's start with the fundamental wave equation. Velocity equals frequency times wavelength, or V equals F lambda. The AFOQT will test your ability to manipulate this equation. For instance, if a wave travels at 400 meters per second and has a frequency of 200 hertz, what is its wavelength? You would rearrange the formula to wavelength equals velocity divided by frequency. So 400 divided by 200 gives you a wavelength of 2 meters. A common trap is forgetting the inverse relationship. For a wave traveling at a constant speed, as frequency goes up, wavelength must go down, and vice versa. The exam might present a question where they ask you to compare two waves, and understanding this inverse relationship is key to getting the answer correct without complex calculations. Next, you must know the difference between sound and light waves. This is a favorite topic for exam questions. Sound is a mechanical wave, which means it absolutely requires a medium, like air, water, or a solid, to travel. This is why there is no sound in the vacuum of space. Light, on the other hand, is an electromagnetic wave and does not need a medium. It can travel through the vacuum of space perfectly fine. An AFOQT question might present a scenario set in space and ask which phenomenon could be observed. Any answer involving sound would be incorrect. Sound waves are longitudinal, meaning the particles of the medium vibrate parallel to the direction of wave travel. Light waves are transverse, with oscillations perpendicular to the direction of travel. Within the category of light, you need to have the electromagnetic spectrum memorized. The AFOQT expects you to know the order from lowest frequency and longest wavelength to highest frequency and shortest wavelength. The order is radio, microwaves, infrared, visible, ultraviolet, X-ray, and gamma rays. To remember this, use the mnemonic, Raging Martians, I invaded Venus, leading X-ray guns. Exam questions will test this directly. Asking which type of wave has more energy than visible light, the answer would be ultraviolet, X-rays, or gamma rays. Or which has a longer wavelength than microwaves, which would be radio waves. Finally, let's cover reflection and refraction. Reflection is simple. A wave bounces off a surface. The key rule for the exam is the law of reflection, which states the angle of incidence equals the angle of reflection. Think of a ball bouncing off a wall at the same angle it hit. Refraction is the bending of a wave as it passes from one medium to another, like from air to water. This bending happens because the wave changes speed. The AFOQT will test this conceptually. A classic trap is confusing the two. If a question describes a light wave hitting a mirror, it's reflection. If it describes light passing through a lens or a prism, it's refraction. They want to see if you can identify the correct phenomenon based on a description. Mastering these distinct concepts, from the wave equation to the properties of light and sound, is essential for a strong performance on the physical science subtest. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.